Hello students, today in this video we are going to take up a topic from chemistry. So let's see what topic we are going to start today. The topic is acid, bases and salts, and this is part 1. If we talk about any chemical substance, they possess certain nature. Like if we talk about the individuals, so everybody has some sort of nature. Somebody is very loving, somebody is not so loving, somebody is very caring. So like we individuals have certain nature, likewise the chemical substances also possess some sort of nature. But their nature is not considered as loving, or you can say caring, or anything else. It is classified as acids or bases. Moreover, we have one category of salts also, which are neutral in nature. So let's study that what actually are acids, bases and salts. The topics we will be covering in this video are introduction of acids, introduction of base, classification of acids and bases, physical properties of acids and bases, chemical properties of acids and bases. We'll do the importance of controlling acidity of soil. We'll do nature of metal oxides and non-metal oxides. We'll study about salts. We'll take up indicators and pH, and we'll also do some techniques of forming, separating and purifying salts. So are you ready to start with this interesting chapter? So let's start. So as I told you that every chemical substance has some sort of nature, like either they are acidic or they are basic, or they are considered to have a neutral nature. We do have one more kind of nature, that is the alkaline, but this alkaline form is somehow related to this basic nature. What is the similarity, or you can say when we can call the substance as base or alkali, that we'll learn when we take up the bases in detail. So earlier it was thought that those substances that are sour or turn blue litmus red and are corrosive are called as acids. So like the earlier attempt by the earlier scientists was that they actually tried to make out that what are the properties of acids or bases or salts even. So they said if anything that you taste is sour or turn blue litmus red or they are corrosive, that means the substance is acid. Whereas if some substances like you taste, if they are bitter, they turn red litmus blue, and when you touch it, if they are soapy in touch, then they are called as bases. But this property of classifying the substance as acid and base just depending upon their touch or their effect on litmus or their taste was not the sufficient classification. So the another concept was given by Arrhenius, that is an accepted concept. So this concept, just based on the physical property, was replaced by the Arrhenius concept. So let's study what is actually the Arrhenius concept. So according to Arrhenius, all the substances which when dissolved in water gives hydrogen ion, they are regarded as acids. So he said, like if I have a substance, let's say we have HX. Suppose I have a substance that is HX and I dissolve this HX in water. So when I add this HX in water, if it dissociate to produce the hydrogen ion, or you can say if it dissociate to produce proton, then the substance, the given substance was regarded as acids. So I think it's clear. So any substance which you can see that possess the hydrogen ion will be an acid, because when we will dissolve that given substance containing the hydrogen ion in water, it will give the hydrogen ion, or you can say it will give a proton. So those substances which when dissolved in water give hydrogen ion or liberate proton are called as acids according to Arrhenius. Example, we have hydrochloric acid. So as you can see that in the formula of HCl, we see that it possesses H. So when it will dissolve in water, it will produce the hydrogen ion and also the chloride ion. So according to Arrhenius, it is regarded as acid. Similarly, we have an example of sulfuric acid. We know that the formula for sulfuric acid is H2SO4. It also possesses H, so that means it will also produce hydrogen ion when dissolved in water. So it is also an acid. Similarly, we have nitric acid. The formula for nitric acid is HNO3. Again, according to Arrhenius, it is an acid. Phosphoric acid formula is H3PO4. So this is also an Arrhenius acid. Carbonic acid we know is H2CO3. So it is also an Arrhenius acid. So I think it's clear that any substance which possesses hydrogen atom in its you can say the chemical formula, then it is regarded as acid, because when it will be dissolved in water, it will liberate its hydrogen ion or proton, and other respective ion is formed according to the formula of the compound, or you can say an acid or a substance. So I think it's clear that how you are going to state about the Arrhenius acid. So as you can see in this figure, we have acids. So we'll just consider first figure, that is acid. So you can see here we are adding HCl, and when HCl is added to water, it is getting dissociated to form the hydrogen ion and chloride ion. So that means the acids are hydrogen ion donators. So if we use this concept for bases, so according to Arrhenius, bases are those which when dissolved in water gives hydrogen ion. So any substance, like say if I have MOH, right, as you can see that it possesses hydroxide ion. So when any substance having this hydroxide ion is dissolved in water, it produces its respective hydroxide ion. So if a substance or a compound breaks to form hydroxide ion, then it is regarded as a base. Like we have calcium hydroxide. The formula for calcium hydroxide is CaOH whole twice. So when it is dissolved in water, it breaks accordingly and form calcium ion and hydroxide ion. So as you can see that it liberates hydroxide ion, so that means it is an Arrhenius base. Similarly, we have magnesium hydroxide. So the formula for magnesium hydroxide is MgOH whole twice. So when added in water, it also breaks accordingly, producing magnesium ion and hydroxide ion. So again, it is an Arrhenius base. So in this figure, we have an example of NaOH. So NaOH also possesses the hydroxide ion. This is the hydroxide ion. So when NaH is dissolved in water, you can see that it is breaking to form sodium ion and the hydroxide ion. So that means it is also an Arrhenius base. So if any substance possesses the hydroxide ion, it is regarded as Arrhenius base. So I think it's clear that how you're going to define the Arrhenius acid and the Arrhenius base. There is one more definition. This, you can say, the base is, this base can also be defined as that bases are proton acceptors. Bases are proton acceptors. Let's classify acids and bases. So let us classify the acids first. Acids can be classified depending upon the source from which they are obtained. Right, like we can obtain the acids from plants and animals. We can obtain it from plants and animals, and also we can obtain from minerals present in earth surface. So accordingly, the acids are classified as organic acids or inorganic acids. As you can see in the figure, these are the fruits, and these fruits are obtained from plants. So they are regarded as organic acids. Even if you obtain any acid from animals, then also it is regarded as the organic acid. And as you can see here in this figure, we have sulfuric acid bottles. Sulfuric acid is somehow a mineral acid because it is obtained from minerals. So that is the reason it can be called as mineral or inorganic acids. So let us learn more about them. Organic acids are the acids that are obtained from plants and animals. For example, if you talk about tomato, the tomato possesses an acid which is called as oxalic acid. In apple, we have another acid that is malic acid. And in all juicy fruits, there is the citric acid. So, I think you got it that what are organic acids. Inorganic acids are acids that are obtained from minerals present in earth. Like we have nitric acid and the formula for it is HNO3. We have sulfuric acid, that is H2SO4. We have carbonic acid, H2CO3, and lots more. So any acid which is obtained from minerals present in earth is regarded as inorganic acid. Now let us classify the acids on the another basis, that is the basis of their strength, that how strong or how weak is the given acid. So let us define the strength first, that by using the word strength, what do we mean, that what is the strength of an acid or a base? See, if I talk about strength, that means the number of hydroxide ion given when acid is dissolved in water. We know that when we dissolve the acid in water, it produces the hydrogen ions. Now, how many hydrogen ions it can actually produce is called the strength of an acid. Similarly, if I use this term for bases, we'll say that it is the amount of hydroxide ion given by a base when it is dissolved in water. So strength simply means the amount of ions they are releasing when they are dissolved in water. So if we talk about acids, depending upon its strength, we can classify as strong acid and weak acids. So all the organic acids, like you can see that in the given figure, we have the fruits, and we know that the fruits are the plant products. So these are the acids which are obtained from plants. They all are termed as weak acids, and all the mineral acids are termed as strong acids. So why organic acids are weak acids and mineral acids are strong acids? So let's make out that what is the difference between the two. If we talk about strong acid, it is the acid that completely dissociates into hydrogen ion. Let's say if I have an acid and I dissolve this acid in water, and what do I get to see? That all the molecules of HX just get dissociated to produce H positive and X negative. That is, in water, we cannot see undissociated molecule of HX. All the molecules are in a dissociated form, that is in the hydrogen ion form, and the another ion is there, depending upon the molecular formula of the compound. So if all the HX, like if we are talking about HX, If all the HX get dissociated into H positive and X negative, that means it is a strong acid, because no molecule of HX remain undissociated. So all those are called as strong acid. For example, we have HCl, that is hydrochloric acid. If we dissolve it in water, all of the HCl molecules will just dissociate to form H positive and Cl negative. It will not be left as undissociated. Similarly, we have sulfuric acid. If we will dissolve the sulfuric acid in water, it will also completely dissociate to form the hydrogen ion and the sulfate ions. So all those that completely dissociates, they are called as strong acids. And if we talk about weak acids, so there are certain acids, when they are dissolved in water, they get partially dissociated. Like if I take the same example and I say that this given acid HX is a weak acid, so what it will show, when it will dissolve in water, it will partially gets dissociated. That means in water we can get to see the hydrogen ions, we can get to see X negative ion, and also we'll be having certain HX as undissociated molecules. So if you can see that the water possesses the ions as well as undissociated molecules of an acid, that means that acid has partially dissociated and it is regarded as a weak acid. So all the organic acids, that is the acids which are present in plants and animals, they get partially dissociated. So that is the reason they are weak acids. And all the inorganic acids, they get fully dissociated. So that is the reason they are regarded as strong acid. So I think you got it, that how you are going to define the strong and the weak acid depending upon their strength. Now let's classify the acid on the basis of water content present in them. So see, if we classify on this basis, we have two types of acids or the categories. One is the dilute acid and other is the concentrated acid. Dilute acid is the one which possesses more amount of water in it, and concentrated acid is that which possess less amount of water in it. This is actually dependent on us. This actually depends on us that how we are forming an acid. If we are adding extra water to it, it will form dilute acid, and if we are adding less water, then it is regarded as concentrated acid. Let's explain this in taking some example related to the percentage. Let's say if I have 98% water and 2% the given substance, right? Like if I say if I have 98% water and let's take 2% as HCl, then the acid form will be dilute because it is having enough water. And if I take like this, that if I have, let's say, 90% of HCl and only 10% of water, that means it has less amount of water, then it will be regarded as concentrated water. This percentage may vary. This is just for an example. So in this case, you are looking at the figure and you can see that there is sulfuric acid. These sulfuric acids are concentrated acid. So likewise, you can prepare them in a dilute form also. So the question is, how one can dilute concentrated acid? It's not simply that if you have a concentrated acid, you will add water and it will become dilute. It's not that simple. The reason being, if you just add water simply into the concentrated acid, the reaction is exothermic in nature. And it can actually liberate so much heat that it can lead to a fire also. So it is not that simple that adding water to a concentrated acid will convert into a dilute form. We have to follow a specific procedure. Let's see what's that. So we can dilute the concentrated acid by adding concentrated acid slowly in water, not water into acid. we add concentrated acid to water, right? And when we are adding, we keep on stirring. We continuously stir it, because when we are doing that, we know that the action between the acid and the water is exothermic in nature. That means lot of heat is liberated. So when we are continuous stirring, what happens? The heat release is comparatively less, because we are adding a small amount of acid to water, and then we are stirring it. So while we stir it, when we stir it, so what happens? That heat is constantly absorbed by water. So it prevents the reaction from becoming violent. So this is how you can dilute concentrated acid, by adding acid to water drop-wise with continuous stirring, not water to an acid. Otherwise it will lead to explosion. Now let's classify the bases. So the first classification is dependent on their solubility in water. We have seen that there are few bases that are soluble in water. So if the base is soluble in water, then it is regarded as alkali. So we can say that alkali is a base only, or you can say that base that dissolves in water is regarded as alkali. And if the base is insoluble in water, then we call it as just a base, not a alkali. So we can say that all bases are not alkalis, because all bases are not soluble in water. But all alkalis are basically bases only. So if we classify now on the basis of their strength, that is how much hydroxide ion are released when they are added to water. So we have the strong and we do have the weak base. So strong bases are those that completely dissociate in water and they produce hydroxide ions. So that means if I have an example of MOH and I want to know that whether it is a strong base or a weak base, what I'm going to do is I'm going to add into water, and if on adding into water it dissociates completely, that is all the hydroxide ions are released and no MOH molecule is left undissociated, that means it is a strong base. So hydroxide of all the reactive metals, let's say hydroxide of NaOH, hydroxide of magnesium, they all are regarded as strong bases because they get completely dissociated. And the hydroxides, or you can say the bases that do not completely dissociate or they get partially dissociate to form hydroxide ions in water, they are regarded as weak bases. So if I consider this MOH as a weak base, what I'll get to see is, if it's a weak base, it will produce M positive, it will produce OH negative, and also there will be some undissociated molecules of MOH. So like we have an example of calcium hydroxide. Calcium hydroxide is a weak base because it gets partially dissociated. Now let's study the properties of acids and bases. That what are their physical properties, and in the next video we'll take up the chemical properties. So if we talk about the physical properties of acids, we saw that they are sour in nature. That means they taste sour. And if we react them with blue litmus, so what effect they have on it? They turn blue litmus red. Initially taken blue litmus turns red. And they are somehow corrosive in nature. Like if a drop of acid or strong acid falls on your palm or on your hand, what you get to see? That there is a burning sensation, because these acids actually absorb the water from our skin, and which leaves behind the burning sensation. So they are somehow corrosive in nature. But all acids are not so much corrosive. Now let's see the physical properties of bases. They are bitter in taste, and if we treat them with red litmus, they turn the color of red litmus to blue. and they are somehow soapy in touch. As you can see in the figure, we have calcium hydroxide. It is a base, so it possesses these features that it is bitter, it turns red litmus blue, and it is somehow soapy in nature. Now let's do few question and answers in order to test that have you understood these topics properly or not. So the first question is, what do you mean by the term basicity? See, we have two terms, one is basicity and the other is acidity, right? This term basicity is related with acids and the term acidity is related with bases. Now what do you mean by basicity or an acidity? See, the number of ions, hydrogen ions produced by an acid when it is dissolved in water is termed as its basicity. So you can say that if we talk about the strength, we can actually use the term basicity for acids. And if we talk about the strength of bases, we have the property acidity, that is the number of hydroxide ions which are released when base is added to water. Like in this example, I have sulfuric acid, and when I actually dissolve the sulfuric acid in water, we see that one molecule of sulfuric acid produces 2 hydroxide ions. Because it is producing 2 hydroxide ions, so its basicity is 2. Basicity is 2 means 2 hydroxide ions are produced, and it is termed as dibasic in nature. Its basicity is dibasic. Similarly, we have HCl. So when we will dissolve this HCl in water, one molecule of HCl will dissociate to form only one H. So its basicity is 1. So it can be termed as monobasic. So this is how we classify the acids according to the strength as monobasic, dibasic, tribasic, like this. Similarly, we can do for the bases as well. Another question is, to which category the acetic acid belongs? See, acetic acid is an organic acid and is a weak acid. So in these given options, we have organic acid, inorganic acid, can be organic or inorganic or none of it. So the correct option is organic acid. Now which acid is organic or inorganic? You have to learn its source. If the source is the plants and animals, that means the given acid is inorganic. And if the source is minerals present in the earth, then it is inorganic acid. Another question is, name the acids that are present in lemon, tomato and curd. So in lemon we have citric acid, in tomato we have oxalic acid, in curd we have lactic acid. So you have to learn the sources for different acids. Another question is, out of phosphoric, that is H3PO4, and carbonic, that is H2CO3, which is a weak acid? So the option is phosphoric acid is a weak acid, or carbonic acid is a weak acid, or both are weak acid, or none of it. So out of these, carbonic acid is the correct option because it gets partially dissociated when dissolved in water. So it is regarded as weak acid. Another question is, what is the value of degree of dissociation for strong acids? As we saw that there is a property called as strength, that is depending upon the number of hydrogen ions it is producing, or you can say, is it getting completely dissociated or it is getting partially dissociated. This property is given as the degree of dissociation, and it is represented by the symbol that is alpha. So for strong acid, this degree of dissociation is more than 30%, and for weak acids, this degree of dissociation, that is alpha, is less than 30%. So this is how you can actually talk about the strength of acid depending upon this property, that is degree of dissociation, that is alpha. Thank you for watching this video. For more learning experience, you can visit to www.wasserex.com. So with this we finished the part 1, and the rest topic, that is the chemical properties and other topics, we'll be taking in other parts.